Work, energy and power. Define work, energy and power, write their units and dimensional formula. That is a question will be asked in the examination. Work. Are you thinking about your homework? But in physics, work has a specific meaning. Today we are going to explore the definition of work. First requirement for work to be done is force. The second thing is a displacement. So work done is nothing but the product of force and displacement. Here force and displacement are in the same direction. So work is said to be done when a body undergoes a displacement parallel to the direction of force, or work is said to be done when the displacement of the position of the body by the application of force. And work is measured by the product of force and displacement of the body in the direction of force. The force and displacement are vector quantities, but the work is a scalar quantity. Very important question for 2 marks. So, even though force and displacement are vector quantities, but work done is a scalar quantity. That is the beauty of these two physical quantities. It is called dot product. Here force and displacement are both in the same direction. Is it possible to have force and displacement are not in the same direction? Yes, possible. Here you see, this person is pulling the car, the toy car. He is applying a force at an angle theta to the horizontal. So displacement and force are making an angle theta to the horizontal. So when the force is applied at an angle to the horizontal, that is to the displacement, then how to calculate the work done? It is given by work done is equal to force into displacement into cos theta. Theta is the angle between force and displacement, or we can say it is nothing but the work done is equal to the component of force in the direction of displacement and the displacement. So it is nothing but, from mathematics, it is called a dot product. Vectorially we can say W is equal to F bar dot S bar. It is equal to modulus of F into modulus of S into cos theta, where theta is the angle between force and displacement. Here again I am repeating, work is a scalar quantity, but the force and displacement are vector quantities. Now we are going to discuss about the units of work. The SI units are Newton meter, simply called as joule or joule. Joule is the amount of work done when a force of 1 Newton moves a body through a distance of 1 meter in its own direction. In CJ system, the unit for work is ergs, and in FPS system, the units are foot-pound respectively. And 1 joule is equal to 10 power 7 ergs. That is the conversion from MKS to CJ system. 1 joule is equal to 10 power 7 ergs. What is the dimensional formula? Work done is equal to force into displacement. It is a dot product, not into, that one is multiplied. But force is nothing but mass into acceleration. From which law? Newton's second law, F is equal to ma. Therefore work is equal to mass into acceleration into displacement. What is the dimensional formula for mass? M. Dimensional formula for acceleration, LT minus 2. Displacement is L. By simplifying, it is ml square t minus 2. So it is shown in the square brackets. So dimensional formula for work is ml square t minus 2. Now energy. Energy is the capacity of doing work. You see here, he is able to lift the weights. That is, she has the capacity of doing work. So that is called, the capacity of doing work is called energy. And energy is a scalar quantity because work and energy are same. But in this case, you see, this person is not able to lift it. That is, he is not having sufficient energy. So he is not able to lift it. so the capacity is less, so his energy is also less. And what is the dimensional formula? It is same as work, ml square t minus 2. Energy is a scalar quantity. What are the dimensional formula? ml square t minus 2, because work and energy are same. What are the units? Same. Joules in SI system and ergs in CGS system. What is meant by power? Power is rate of doing work or rate at which work is done. So, power is equal to work done by time taken. Power is equal to W by T. This is called average power. So, rate of doing work is called power, and power is equal to work by time. It is called average power. The power at a particular instant of time is the ratio of work done to the time interval dt around t. So, power is equal to dw by dt, or dw is equal to f bar dot s bar. Now, ds is a small displacement and f is the force applied. Therefore, power is equal to, instead of work, what we can write? F bar dot ds by dt. ds by dt is called velocity. So, power is equal to f bar dot v bar, or it is equal to modulus of f into modulus of v into cos theta. Theta is the angle between force and velocity component. So, power is a scalar quantity. So, here power, energy and work, all three are scalar quantities. Here power is also a dot product. So, it is work by time or f dot v. It is a dot product. So, what are the SI units of power? Joule per second or joule second to the power of minus 1, or simply watts. When 1 joule of work is done in 1 second, the power is equal to 1 watt. So, 1 watt is equal to 1 joule by 1 second. Dimensional formula for power. Power is equal to work by time. It is equal to Fs by T. Force is ml t minus 2 into L by T. If you simplify, it is ml square t minus 3. Therefore, the dimensional formula for power is ml square t minus 3.